Hey, Honors Chemistry. Now we're going to continue into our Unit 6 Important Information Notes, and we're going to start on page 5. Now, there's going to be a very useful handout that you're going to be wanting to use for the next couple of days in class, and it's our common ions for chemistry. We're going to be taking this and using this for the rest of this unit, and it's going to be super helpful for you to remember eventually the charges of the elements. We just started talking about elements kind of combining in a specific ratio to form compounds, but we didn't get a chance to really dive into that in the classroom. So for our notes, I'm just going to skip ahead a little bit and identify charges of elements for us. So this is group 1A. 1A tends to form +1 charge. So things like hydrogen will form +1, lithium +1, sodium +1. Things in group 1 tend to form +1 charge. Things in group 2, or elements in group 2, tend to form 2+ charge. So like beryllium and magnesium will form a 2+ charge. These elements here, silver, even though it's in the middle here, we're going to talk about what this middle is. Silver will form a +1 charge. Zinc will tend to form a +2 charge. So keep that in mind. Then group 3 elements, even boron up here. Group 3 elements tend to form +3 charge, so things like aluminum and gallium will form a +3 charge. That's our positive charges, and those, if you remember, except for hydrogen, are our metals, and they form cations, which are positively charged particles. So on the left side of the periodic table, if you remember, these are mostly our metals that form positive charges. Now if we look at our nonmetals over here, nonmetals, you're going to see that they typically form they're going to be anions and typically form negative charge. The only group that doesn't is group 8. I'm going to make a note here that this is group 8. And it's known as the noble gases, and they are inert, which means they do not react. So group 8 elements here are noble gases. They do not and will not have charges that they form readily and easily. So we call them inert gases. They do not react. So let's look at nitrogen. This is group 4. We're going to skip it right here. Group 4 we're skipping, and you're going to see that later. Group 5 elements tend to form -3 charge. So nitrogen tends to form a -3. Phosphorus tends to form -3. Group 6 elements here, and this is 7. This is group 8, like I said. Group 6 elements tend to form -2. So oxygen is O2-. And then group 7 elements tend to form -1. So things like fluorine will be -1, chlorine will be -1, bromine will form -1. And these charges that they form are the reason why they combine in a specific ratio. If you remember our work in class with formulas, there was a formula between Be and Cl. Be needed 2 Cl's. That's because Be is 2+ and Cl will be forming -1. So in order for those to interact in a neutral way, I would need 2 Cl's and 1 Be. We're going to see that in these notes. Okay, so keep these charges in mind. You're going to eventually have to remember and memorize them, but for right now, we're just starting with them. So let's talk about these compounds and naming them first. So if I had this compound, NaI, the way that I would begin naming it is first I have to identify and name each element in the compound. And by the way, now we know that this is an I because it's got those two things on bottom and top. So NaI, Na we know is sodium from the periodic table, and I from the periodic table is iodine. If I want to name an ionic compound, and again, this is going to be ionic, and it's simple. Ionic compound, because we got metal, which is our sodium, and non-metal that have interacted. That's our iodine, sorry, not chlorine. We got our sodium and iodine. Metal and non-metal. An ionic compound for right now is going to be metal and non-metal. Positive and negative charge eventually. So the way that I'm going to begin naming it is I know I'm going to name, just from my own knowledge, sodium as is. I'm going to do something with this iodine, which is my nonmetal. I'm actually going to change the ending of iodine for the name to iodide for the name. And so NaI really becomes sodium iodide. So it looks like I keep the original name of the metal cation first, and then I look at the name of the negative anion or nonmetal, and I'm going to change the ending of it to IDE. So I'm going to do that again, and then I have the rules here. So if I had CaCl2, I have Ca and I have Cl. And I'm going to let you know that the number of Cl's does not matter, but I have Ca and I have Cl. So for Ca, I'm going to name that as calcium. Calcium is my metal cation that I'm going to name as is. Metal cation that I name as is. And then chlorine, Cl, that's chlorine. And like I did on top here, I'm going to change the ending here to chloride, IDE. And so this compound now is named as calcium chloride. So that is the beginning of us naming ionic compounds. I'll eventually need the charges for something else later, but that's the beginning of us naming ionic compounds. So here are the general rules for naming simple binary ionic compounds. Identify and name cation as is. And for us, the cation is the metal that's on the left in the formula. Just like a little simplification for you. So the cation is the metal that's on left, and we know that cations are metals, and metals are cations. We just name it as is. So I find the name on the periodic table, boom, name it. And then the second element, or the second ion, the anion, we identify and name the anion with IDE ending. The anion will tend to be a non-metal, and it's on the right in the formula. Okay, so now let's make sure that we could apply this for simple ionic compounds. It's going to get a little bit more challenging later, but for right now, we're going to do this for simple ionic compounds. So let's skip to page 8. Let's skip to page 8 and do that for the first 4 examples here. So using those rules, it says identify and name the cation as is, and then identify and name the anion with IDE ending. Let's do 1, 2, 3, and 4. All right, so for number 1, I have Na and F. Okay, now Na is my metal, and it's my positive cation. F is my non-metal. It's going to be my negative anion. And if I didn't know that, I talked about in the beginning of this video which elements have specific charges. So Na, metal, positive charge, and then we have F minus non-metal, negative charge. And so now if I want to name this, I'm going to have Na is sodium, and F is going to be first fluorine, and then I change the ending to fluoride. So this compound becomes sodium fluoride. That is what NaF is. And that's for a simple binary ionic compound. Let's do number 2. Element on the left is going to be my cation, which is my metal. Sr is definitely a metal. Sr is right here. It's in group 2, and this is where all my metals are. So I have Sr, and I have Br. I'm going to let you know right now, this little 2 does not matter for right now. For simple binary ionic compounds, this little 2 doesn't matter. It doesn't matter how many of each. We're going to see that in number 4 and in number 3. Sr is strontium. Gonna write that down. Br, we might know this from before, is bromine. Bromine. And if I want to name this, I name the metal cation as is, so we're good. And then I have to change the ending of the non-metal anion to IDE. So this becomes strontium bromide. Looking at number 3, we have Ca3N2. I'm going to do quick and shortcut now. I'm going to talk out loud instead of writing all my work here. I know that on the left is my metal cation. I'm going to name it as is. Ca is calcium. I'm going to let you know that little 3 and little 2 doesn't matter. Subscript does not matter right now. We're going to use that later. For simple binary ionic compounds like we're doing right now, doesn't matter. Doesn't matter if I have 50 of these. I'm going to name it the same way. So I have calcium, and then N is nitrogen, and I have to change the ending of nitrogen to nitride. So I name the metal as is, and then I change the non-metal ending to IDE. And then finally, I'm going to do the last one even quicker to see if you get the idea. I have Al, which is aluminum, and O, which is oxygen. I'm going to name that as aluminum oxide. And that is how I name simple ionic formula. What I would like you to do now is get in the habit of being able to name simple ionic formula. Work on just questions 1 and 2 here. And I'll post a video answer key to kind of help you out with this questions connected with this. But we're going to start with you naming these ionic compounds. So you might want to write the general rules up here for ionic nomenclature and naming it. I'll do that in another video. But start by naming some of them. So I could do like 1A right away. Na2O. My metal cation on the left is sodium. I name it as is. And then my non-metal on the right, I'm going to name that's oxygen, but in a compound, I'll name it as oxide. Na2O is definitely sodium oxide. So to make sure you get this idea of naming simple ionic formula, just work on questions 1 and 2. So 1A through H and 2A through E. I'll even get you started on 2A. Na3N, Na is sodium again. And we saw that N is just nitride. Sodium nitride. So use this video, and I would pause here on watching videos unless I have other videos with more answers to this. Work on understanding how to name simple ionic formula. Make sure there's a metal and non-metal. Do B through H and B through E. Once you're done with that, move on to my next video where if I give you the name, how can I write the formula? Let me know if you have any questions or concerns about naming simple ionic formula. On Monday, we are going to have a quiz related to all of this information.